Hello everyone, and welcome back to my channel. This is Vishnu Manchapudi, and I am glad that you are here. Today, we will be solving problems 7 through 9 of the 2017 AMC 8. Problem 7. Let z be a 6-digit positive integer, such as 247247, whose first 3 digits are the same as its last 3 digits, taken in the same order. Which of the following numbers must also be a factor of z? Now, we know that the number z is of the form a, b, c, a, b, c, where a, b, and c are digits, and everything here is just one number. So, writing this in base 10 notation, we have that this number is actually going to be equal to a times 100,000 plus b times 10,000. This one's 100. Plus c times 1,000 plus a times 100 plus b times 10 plus c times 1. Now adding everything up, we have that this is equal to a times 100,100 plus b times 10,010 plus c times 1,001. And we can factor out a 1,001 from each of these terms to get that the number is simply 1,001 times 100a plus 10b plus c. And since a, b, and c vary, we know that the number that must be a factor of z has to be a divisor of 1,001. So we just look at all these numbers and see if they're a factor of z. To do this, we first check the prime factorization of 1,001. Looking at small primes, we note that 1,001 is equal to 7 times 143, and 143 is just 11 times 13. Now, looking at the answer choices, we see that 11 is in the answer choices, and we know that it's a divisor of 1,001, so that's our answer. Problem number 8. Malcolm wants to visit Isabella after school today and knows the street where she lives but doesn't know her house number. She tells him, "My house number has 2 digits, and exactly 3 of the following 4 statements are true. 1. It is prime. 2. It is even. 3. It is divisible by 7. And 4. One of its digits is 9. This information allows Malcolm to determine Isabella's house number. What is its unit digit? So, since we know that 3 of the 4 statements are true, that means that we know that 1 out of the 4 statements is false. And to find the false statement, we can just look at pairs of statements that contradict each other. Right off the bat, we notice that statement 1 and statement 2 contradict, since there's no even primes besides 2, which only has 1 digit. Additionally, 1 and 3 also disagree, because a number can't be prime if it's divisible by 7, except if it's 7, but the number has 2 digits. Thus, since 1 conflicts with 2 different statements, it must be the false one. Otherwise, there would be more than 1 false statement. So now that we know that 1 is false, the number is even, divisible by 7, and one of its digits is 9. Since it's even, the tens digit is 9. And now, we note that 7 times 14 is equal to 98, meaning the unit digit is D, 8. Problem 9. All of Yan's marbles are blue, red, green, or yellow. 1/3 of her marbles are blue, 1/4 are red, and 6 are green. What is the smallest number of yellow marbles? So, for this question, let T be the number of total marbles. We have B is equal to the number of blue, G is equal to the number of green, R is equal to the number of red, and Y equals yellow. So now we read the problem statement and see what equations they give us. So we first of all know that all of Yan's marbles, so all of them, which is T, are blue, green, red, or yellow. This means that T total is equal to B, which is blue, plus G, which is green, plus R, which is red, plus yellow. Y, yellow. So that's the first equation they give. We also know that 1/3 of the marbles are blue. So B is equal to 1/3 T. 1/4 are red. So we know that R is going to be equal to 1/4 T. And G, which is green, is simply equal to 6. So plugging these values back into the initial equation, we have that T is equal to 1/3 T from the blue plus 1/4 T from the reds plus 6 from the greens plus Y. Subtracting 1/3 T and 1/4 T from both sides, we have that T minus 1/3 T, which is 2/3 T, minus 1/4 T, which is 5/12 T, minus the 6 from the green is going to equal Y. So now we want to find the smallest number of yellow marbles. And here we use the key insight that the number of yellow marbles is an integer. Thus, T must be a multiple of 12. Since 6 is an integer, 5/12T must be an integer. So now it's just trial and error. Well, first of all, if T equals 0, then we have Y equals 5/12 times 0, which is 0, minus 6 equals 6. Negative 6. Negative 6 is not greater than 0. You cannot have negative marbles. So this one fails. Next one, we have T equals 12. Then we would have Y equals 5/12 times 12, which is just 5 minus 6 equals -1. -1 is still less than 0, so this case doesn't work. Now let's check t equals 24. You know the drill. We have y equals 5 over 12 times 24. That's 5 times 2, or 10, minus 6, equaling 4, which is greater than 0 and valid. Choice D. Thank you so much for watching this video. It really means a lot. Please don't forget to like, share, and subscribe, as well as click the bell icon. As always, if you have any questions, comments, or concerns, please post them down below or email me at cnaspirations@gmail.com. This is Vishnu Manjipudi, signing off. Bye.